So what kind of stuff?
It could be anything and everything. As it pertains to this particular seminar, obviously we do some work in all solid state batteries and we'll just say energy storage overall. And so we have a fairly good perspective on kind of what new R&D concepts and ideas are happening at any given time.
Cool. So we got a question for all participants. Zoom text us your answer, and Gabe will look for those, and we'll put them up on the whiteboard after a bit. But what non-legacy EV developer manufacturer do you think has a chance to be a breakout company? And if you got a reason, that would help. You know what they got that's special, or why you think that they might be a breakout company. Okay.
And Steve, just to clarify, this is obviously excluding Tesla because they've already kind of broken out.
I put that up there, but I thought it was better just to, yeah.
Okay, leave it open to interpretation.
The most valuable automobile company in the world, so I think they're not really a legacy, but they have definitely got there.
They've broken out.
Yep, they've already broken out. Okay, so I saw this article in a bunch of different places. A Waypoint blog, which is the official Waymo blog, says Waymo is opening its fully driverless service to the general public in Phoenix. And there's two issues here. A, it's partial. They say they're going to go within 50 miles of, Glendale, whatever it is, the city down there where they operate, the suburb of Phoenix. And but they also, the thing is a little confusing because they also have, they have a note that says that the drivers are coming back in 3 weeks or something like that. So it's not real clear if this is a permanent thing, what the deal is. And also they got Twitter bombed by Elon Musk, who said it's a partial solution. I guess he's saying they're fudging because they're operating in Phoenix and there's no weather. And I would say good for them. That's a smart way to do it. Agile your way into it. But we're going to talk about this in December. Rahul is going to have plenty to say about it, I'm sure. By then they'll be more broken out about it. But it's a big deal. It's an important issue, important article. We've been talking back and forth about Nikola stock and Nikola as a company and GM and what they should do. And, Nikola had some issues about their prototypes. We talked to them about a month ago, Mike and I, and our one question for them is, how many prototypes do you have on the road? And their answer was, we can't tell you that.
Because they don't have any.
Yeah.
Sorry.
That's Mike. Yeah. This all came to light in a report, and but this has to do with they had a cool plan. I have to say, I read the plan, and it wasn't the plan that was the problem, it was the implementation that was the problem. The plan was pretty well thought out, and they had a plan for fuel stations around the world, and they had a partnership with BP, but BP's backed away from it. And so I think that puts more pressure on GM. Mike, you have comments about that one. What do you think?
I think this is again, a no risk option for GM, really.
As long as the cash is there,
What's that?
As long as the cash is there, I guess that's true.
Yeah, I mean, Nikola has the cash. They completed their SPAC transaction, so they have cash, so they can pay GM for their engineering design and the actual pieces of equipment. GM's not putting any money to this. So it just helps increase the volume for their own batteries and their own fuel cell systems, and they get to deliver. The only risk is Nikola doesn't do well on a customer standpoint and puts out really bad products, so it could be a reputational thing with GM. But from a financial perspective, it's a no-lose situation. They get a big chunk of Nikola stock, and they get volume, and they get paid to do this. So,
yeah. So I would say that, it does depend on who actually produces the vehicles. Because, there have been a lot of deals in the past where Toyota, I don't know, it's not the Toyota Matrix, but the Pontiac Vibe is made by Toyota, and blah blah blah. They just rebrand something, and what usually happens in that kind of deal is the guy who's the manufacturer wins, but we'll see. Okay, Amazon unveiled its Rivian-made electric delivery van. Oh, there it is. Looks like an electric delivery van. But it's real. It's on the road. Rivian is a truck manufacturer. They've got pickups coming out, et cetera, et cetera. But they did their deal with 100,000. Their how should I say, their financial underpinning was 100,000 vehicle order from Amazon. And there's the front of the vehicle. And you tell me, but I think it looks like the new little Honda EV. But oh well. I guess if you're going to copy somebody's headlight assembly, Honda's a good one to do. Quiz answers. What was our question? Our question was, who's a breakout EV company that isn't a legacy vehicle and isn't Tesla, who's already broken out? Do we have any answers?
We do have a few answers.
All right.
I'll put them up on the whiteboard. Okay,
can you show us the whiteboard? Do you have to do that, or do I have to do that?
No, I can do it. I think I can do it.
Let's put Hercules up there. That's Mike's company that they're pairing with, and they've got the guy that did Hercules, if I remember the story correctly, Mike, was a former GM guy. He helped do the Hummer design, et cetera, et cetera. So he knows those kind of vehicles, and he started a new company, and that's who you're paired with, right, Mike?
Correct. He actually was at Ballard Power Systems back when I was, and he started with the Ford side of the partnership that we had and worked on the Ford Focus fuel cell vehicle. Did that in the engineering standpoint. Then he had a stint at Ford doing electric vehicles as well as GM. He did the Bolt, did the engineering design for the Bolt, as well as launched the Hummer as a design and such. So he obviously left GM before that product gets into the market, because it's hitting the market later this year or early next year.
Cool. I would put NIO in there. NIO actually had a stock. They're a Chinese company, which is one thing that's going to start happening. You can see Chinese companies start coming into the market because they've got a lot more vehicles operating in China. But NIO, it has battery as a service, and so they will take your battery out and charge it or do whatever they need to do to maintain it, and that's an interesting proposition. And they actually put out, I think they had an offering in the New York Stock Exchange. So they're a Chinese company, but they've got some U.S. presence. And who are the guys that just opened in Beverly Hills? The guys that have the really low coefficient of drag. I'll think of it. I would say those guys are coming on.
Hyliion and Canoe. Canoe I've heard of. Lordstown Motors, I know, is up and coming. Jerry Rohn mentioned something very interesting. Tri-Track Motors, it made me want to Google them. They're offering 180 mile an hour legal travel on solar-only power. Now, that's got to be intriguing. I don't know if we want to let Jerry tell us what that's all about for a minute or two.
Yeah, Jerry, give us a quick 30-second background on Tri-Track or whatever.
Okay, Tri-Track Motors. We're here in Austin area, Leander. And we have a monorail, dual mode electric car that drives on the street, and then it converts and goes up on the monorail. And on the monorail, it gets 180 miles an hour, and it's powered by a 7-foot wide solar array that's just under the guideway.
Oh, cool.
Here, I'll share. I've pulled up a photo, and here you can. I don't know.
We're okay. We got to roll.
Can you see my screen?
If we don't get to the main one, we burn up too much time with these people. So I'm sorry about that.
All right.
There was Canoe. There was those guys. There was somebody I thought we needed to bring up. Anyway, there's a lot of them, and I think the point of this is that legacy car manufacturers don't necessarily have any, as much hold on the market as they used to be. It used to be them and nobody else. Now it's everybody else and maybe them. And so that's my conclusion. Anybody disagree with that? There's always hope. A little friction is good for the program. Okay, go ahead. Who said that?
I was going to say, I'll add that, I wouldn't count out the legacy auto manufacturers. And
I know who it was.
Look at a Volkswagen. They've put $26 billion or putting $26 billion over a 2 or 3 year time window. They're working with a number of different battery manufacturers. They're developing their own platforms. They've got an enormous amount of money. They got the distribution system, the supply chain, everything else. Plus, they know how to make cars. And making a car is not necessarily an easy thing to do. It's a challenge. You got to be able to operate at high altitudes, low altitudes, high temperatures, low temperatures. You got to start, stop, vibrations. I mean, there's a lot goes into building a car and doing it so that it works. So I wouldn't put out, people like GM, Volkswagen, Toyota. Some of these guys are putting a boatload of money to this. I am partnered with a small upstart, and I think one of the advantages of a small upstart like a Hercules is that they don't have the bureaucracy of a large auto company. Yeah. So they don't, they can move quickly, they can test quickly, their decision making can be done quickly, so they can move.
Put this in another. You just said in another way of betting, Frank. GM and legacy car companies have the money to make bets. They just don't have the institutional capacity to formulate the bets. Well, they can't.
They have a much larger challenge. So for an auto company like a Ford or a BMW or something like that, it takes them 7 to 10 years to develop a new platform. It just takes them a long time. Where a small startup like Lordstown or Hercules or Rivian, they can move quickly. They can do it.
I forgot Rivian. We didn't put them on the list, but they're on the list. I guess they've arrived. I don't know what we put them in that technical thing. So, okay, we're going to keep going so we can get you guys started. If it works, Toyota's fuel cell semi-truck could doom the startups. This also applies to batteries, apparently. Mike was telling me the other day he thinks the looming in the woods is big old Toyota coming out with, who's been working on solid-state batteries forever, et cetera, et cetera. Fuel cell semi-trucks built by Toyota could be a big deal. I think they have about 1,500 of them in LA. Did I read that correctly? I think we talked to somebody about that, or whatever. Okay, so 46 new electric buses in Anaheim. Anaheim has something called the Anaheim Transportation Network, which deals with Disneyland and all the resorts in Anaheim, et cetera, et cetera. It goes down as far south, I guess that is, as Costa Mesa, whatever. But they've got a 20-year charging as a service agreement. So this is essentially an IPP, independent power producer. They're using solar canopies, and they've got a separate charging station, I think, for each of the buses, et cetera, et cetera. So it's an interesting option. I think it's pretty cool. It's a cool way to go about taking care of your charging infrastructure. If you're I can see other commercial operators doing it, trucks, package trucks, etc. So that's it. Okay, Solid Power is delivering its first generation all solid state battery. I guess we have an article about Mercedes-Benz that has a new vehicle out as well, but it has a solid state battery. But it's got a lot of compromises to it. You have to keep it plugged in. You got to do this. You got to do that. So I don't know about this new solid state battery that Solid Power is delivering. It sounds like a partial solution. They need to get stuff out and get it on trial out in the real world to make it work. Any comments, guys? I'll let you guys jump into this if you want to when you get into your discussion. And then the last thing we're talking about is Hercules Electric Vehicles and Prieto Battery Inc. establish a strategic partnership. So that's an example of somebody making bets. A smaller operator, essentially, they're going to come out with lithium ion a little bit earlier, but your thing is coming out in 2025. Is that right, Mike?
Yes, that's our target date.
Okay, well, I would ask you, the first question is okay, when are you going to have your prototypes on the road? But I'm going to let I saw James' slide deck, and he's getting into the whole what the steps look like. So we'll let you do that. And I'm going to introduce Mike and James. They're going to do the deep dive. Again, Mike is the CEO of Prieto Batteries, and James is CTO of Forge Nano. And they're going to talk about the current status and future promise of solid-state batteries. Go for it, guys. Do we need to do anything? Let's see.
I'm going to share my screen because I got a few slides.
Okay, I think I set it up so anybody can share. So see if that works.
Got it.
All right. We're off to the races.
All right. Sorry about that for the delay. As I mentioned in the intro, I spent 10 years at Ballard Power Systems from 1998 to 2008. And what I'm going to do before I give it to James and he gets into the details from a technology perspective on solid state, I was going to set the stage for where we are today and how we got here and where we're headed in the future. And in a lot of ways, it started back in the early 90s when the California Air Resources Board required zero-emission vehicles. They said 2% in 1998, 10% in 2004. And basically they said, as an auto company, if you want to sell any cars in the state, you have to have this percentage of zero-emission vehicles or have credits to do that. So a lot of companies went out and they delivered vehicles, the GM EV1, Honda EV Plus, Ford Ranger, Chevy S10, Toyota RAV4. They put them out there, they tested them, some of them leased, some of them sold. But the bottom line was that all these vehicles were compromised vehicles. They lacked range, they required long charging battery times, there were safety issues, they didn't perform well in cold weather, they lacked space in the vehicle because the batteries were so large, and they're way, way too expensive. So very, very much a compromised vehicle, which when I was at Ballard Power Systems, we were able to use and explain to them why fuel cells were going to replace the internal combustion engine, not batteries. So then let's take a step forward. In 2012, Tesla launched their battery electric vehicle. It had extended range, it was a luxury sedan, and it had high performance. It had room for 5 people, had a trunk. So from that perspective, it really wasn't a compromised vehicle. They also installed some of the infrastructure. So with hydrogen fuel cell vehicles, they didn't install the infrastructure. So there was that chicken and egg thing. But Tesla actually installed some of their own infrastructure. So they had infrastructure so you could drive the vehicle everywhere. China made a big push for battery electric vehicles. So at the end of the day, from 2012, you got a lot of significant improvements being made. And we sold around 3.8 million battery electric vehicles were sold in 2019 worldwide. So they made significant progress in the batteries. They've increased their energy density over the last 20 years. They've lowered their costs, and they've developed really good battery management systems to help mask some of the deficiencies of these batteries. And so now you're seeing a big push for battery electric vehicles. I only got one of the notes here, just 2 weeks ago, I believe it was, the governor in California signed an executive order by 2035. All new car sales have to be zero-emission vehicles in the state of California. They're joining a bunch of other countries that are phasing out the internal combustion engine. So there's a really big push for battery electric vehicles, zero-emission vehicles that is happening worldwide right now. And I think a lot of people would say, oh, that's great. We're getting this huge demand. Things are increasing. You've got auto companies like VW saying they're going to have 70 different versions of or different cars by 2025. GM is saying 20 to 25 by 2023. And so you can see this curve, and this was a projection that I developed through a number of different sources, saying in 2020, you're looking at about 3.8 million cars, maybe a little bit less because of COVID, but it's going to ramp to over 20 million by 2030. There's some people that are saying it'll be higher than that. It'll be more like 30 to 40 million by 2030, and that's new car sales. So there's going to be a huge increase in battery electric vehicles by that time frame. But to achieve those forecasts, I'm going to argue that batteries are still not good enough. the lithium-ion battery that we have today is still not good enough. It doesn't provide you the range necessary. It does in high-performance luxury vehicles where you can put a lot of batteries and you can cover the cost of those batteries because it's a luxury vehicle. But in standard low-cost vehicles, or like a Honda Accord or something of that nature, you can't put enough batteries on because otherwise the cars become way too expensive. So you have the range issue. Then you have the charging issue. Today they talk about fast charging, but even fast charging takes an hour. Most of the time you need to charge it overnight. And again, the cheaper the car, the longer the charging is because the batteries are less advanced. There's still the issue of safety. I saw that today in an article that the Chevy Bolt is being investigated for fires for the last 5 years for their operations. So they are worried about their spontaneously combusting. So lithium-ion batteries have that issue because they use liquid lithium as electrolyte. They don't operate really well in cold weather or hotter weather. We still have to lower the cost. They've done a great job in doing that, but they're still not there yet. And we need better cycle life. So in my mind, today, the battery electric vehicle has improved immensely from back in 1998, 2000, but it's still a compromised vehicle. I've got a nephew that drives from where I live downtown. It's about 35 miles, and he has a Nissan Leaf. In cold winter, he cannot drive that car because his 150-mile range shrinks to about 75, and he's worried about getting stuck on the road on the way back. So these vehicles are still compromised vehicles. And just to kind of set this up to kind of support this, I found a couple quotes in a couple surveys and such. One from KPMG did a survey of 1,000 auto executives a couple years back, but they said that they believe battery electric vehicles will fail commercially due to infrastructure challenges and recharging times. So they're basically saying the recharging and range anxiety issue will cause these vehicles to fail. I'm not sure I'd go that far, but I don't think you're going to get mass adoption. And then in December 2019, a study done by Research and Markets Report said that the growth of solid-state batteries is going to grow and is necessary because the enhanced safety of solid-state batteries. They have a better ability to operate in low and high temperatures, and they have better range. So in many ways, I think, again, people are recognizing this, that if you're going to replace the internal combustion engine with a battery electric propulsion system, you're going to have better batteries. And there was an article yesterday in Forbes talking about the European experience. They're expecting the ramp up of new vehicles sold to be 10%, going from 3% to 10% in the next year. But then they're saying it's probably going to level off. The growth is being done by the regulations, emission limits. But then they talk about the fact that in Europe, the highway cruising speed's about 80 miles per hour. And at those speeds, all batteries lose about half their range. So now you have a car that's, instead of 200 miles, it only gets 100 miles, and charging is still an hour or more. So you can't go cross country. You can't drive across Europe without having a significant compromise in your travel. So my premise is we need solid state batteries. We need batteries that can address these issues, whether they're solid state or how that works. We can debate after James gives us a little bit more detail on solid state. So with that, I'll stop sharing and I'll turn it over to James.
I figured it might be worth a moment just to make sure and introduce myself, because I'm not the CEO of a solid state startup, but I did start one. And I do a lot of work in, like I had mentioned, innovative material science solutions. For Channel, that's kind of what we do. We commercialize the next gen stuff. And I'll get to that in here in just a moment, but just to give you an idea of how big we are, I listed out a few things here. We've been around for about 7 years. We have 50 employees. You can Google us. We got a bunch of investment from VW and LG and a bunch of other partners. We've been doing a lot of work in the battery space as our focal point, just due to this sort of EV revolution, and as a result have gained quite a bit of experience in that realm, which does include solid state battery work. And one reason I'm interested in here is that's what I did my PhD work in, and over a decade ago, and still have a passion for it and still do work on it, both with and without partners. Forge Nano, as I mentioned, does a lot of material science work. It is our intent to commercialize the technology. It's been around for quite a while, and we're well on our way. We've closed some investment and merged with a few of the other local companies that were doing similar stuff that I've shown here, but that's for a different discussion.
James, you moved out of Louisville. That was what got me. You moved over to...
Yeah, I know. We ruined a little trifecta there with Solid Power and CU and that whole thing, but we're not too far away. We're in Thornton.
Right off 25. I guess it's a lot more convenient for people to come see it.
Yeah, we took over the old Ascent solar building.
Cool.
So, in any case, I've tried to condense an entire deck into one slide here, but for the most part, what we do is commercializing products with atomic layer deposition. If you haven't heard of it, it's basically a coating technique to upgrade materials. A lot of people in the battery industry are interested in it for improving, chemistry and electrochemistry, especially around cathodes and anodes, solid electrolytes, you name it, to increase stability, whatever that means, whether it's SEI formation or longer cycle life, fast charging, what have you. ALD is a toolbox to enable the key stuff that you need, and we do that on all forms of substrate. The ticket is that it improves surface properties. I've listed dozens here of different areas. Usually in batteries, it's conductivity focused, but it doesn't matter, right? It's a platform technology. It can be applied to anything and everything. But for today, we're obviously talking about energy, but just wanted to make sure you guys knew why I'm sitting here. So, as Mike mentioned, obviously there's a lot of hype about solid state, and I don't mean that negatively. It's an excellent thing that I'm absolutely bullish on solid state. It's the timeline that I'm not sure about. So, we've seen a number of different headlines coming out from Toyota and Samsung and Hercules and Prieto, right? Very exciting. Solid Power, Dyson, though, they're probably the greatest example where they said they would have a car this year, but they don't, right? So there's some fundamental difficulties in there that are being realized, unfortunately, because if you trace announcements over the past 3 years, a lot of those are not happening at this point. So kind of the question is, when is it actually going to happen? And I want to pause the high level for a second to make sure and visit something I think is important. First of all, there's always a lot of pushback. People say solid state batteries are already out there. They are, but they're the hearing aids, and they consume 2 kilograms of cathode powder a year, not 200,000. So tons, that is. So these are very, very different markets with very different scales. And so as it pertains to electric vehicles, right, it's this sort of solid versus liquid, and we have enough challenging issues with just lithium ion at the moment, let alone solid. And while solid offers benefits of being safer, more energy dense, and lower cost, and there's a lot of very good research articles that come out about this, there is a question of, are they actually safer, more energy dense, and lower cost? And I'm not 100% convinced yet, because, for instance, while a solid state battery, you may not have a fire, when it comes to sulfides, that may not matter. You might still end up with the generation of an H2S gas if you get into a wreck, which will wipe you out just as fast. And then as far as energy density goes, lithium ion is holding a pretty high bar, and while solid state can theoretically beat it, to my knowledge, it doesn't yet. And one example is that it's not an apples to apples comparison between the loading of cathode in the electrode of a lithium ion battery versus a solid state battery. There's a big difference there that it causes some reductions. And so I'll say that there is some devil in the details. And then as far as cost goes, from what I see, processing is really where there's going to be a big part of cost, because maybe the materials could be one-to-one, but to this point, solid state still requires significant air and moisture sensitivity equipment. And that's not cheap. Here I'm showing a dry room, and I'll say that the for instance, the solid state electrolytes, they are much more moisture sensitive than your average battery material, which are often already moisture sensitive. So with that, the things that I see as a critical focal point of industry moving forward is focusing on reducing that moisture sensitivity, because if you can, that's where a lot of the reduction in process costs will come from, as well as safety, right? Because if you don't have to worry about this immediate reaction happening, it not only helps you create the battery, but on the backside, if somebody gets in a wreck and the thing splits open, you're not looking at a really fast reaction that creates a toxic gas. And I'm still talking about sulfides, for instance. Obviously, there's oxides in different kinds, but this discussion can go all day if we wanted to. So what I'm focusing on here is or saying that needs to be focused on is processing costs and reducing that moisture sensitivity, as well as ensuring that there's a good interfacial contact of these solid systems. Yes, there's different variants of solid state, all solid state, what have you, and how these things come together, but it's not liquid, where you have it contacting anywhere and everywhere, literally fluidly. In solid state, it's exactly what it sounds like, and you have particles contacting particles, which isn't an easy thing to overcome mechanically, just the way that they touch each other, and then physically, sort of with what's happening where they do contact each other. And there's a lot of interfacial issues that need to be resolved there. The picture I'm showing is from ion storage systems. It's just one example where they sinter together, and it works. You've got good interconnectivity, but it's also ceramic, so it's breakable. So there's always compromises, which Mike had mentioned, and those are going to be a lot of the challenges going forward. But I do think that it's not necessarily just going to be a CapEx issue. It's going to be an OpEx, operational processing issue. So kind of to give you a high level of what I see, with regard to solid state batteries is we've got a steadily increasing barrier to entry from lithium ion incremental improvements, right? There's a lot of people with a lot of focus on them that are slowly increasing the performance. And so while we're working on solid state, the bar is not fixed, it's rising to overcome, to have that value proposition. There's been a concept from a number of people that solid state could leapfrog lithium ion in the near term. And for instance, this was probably 1 or 2 years ago, this was a big concept that people said, well, let's let China just have their gigafactories and we're gonna leapfrog this with solid state. However, I think it's important to note that with the increasing global need of energy storage, which you could glean from the battery day slides and these terawatt-hour factories and all this stuff, people want these systems. People are building gigafactories all over the place, and they want them to operate for a long time, right? That's how they offset their own costs. So there's an infrastructure issue rising or being built against solid state as we speak. And that's not to mention that the general timeline for adoption, especially in EVs, the legacy EVs at least, is very difficult. And I have high hopes for Mike and Hercules, but generally, the vehicle adoption of new technology is a very time-consuming, near decade-long process.
Let me stop, James. I hear a conflict brewing. You guys disagree on something? Did I hear that?
Can I finish real quick and then we jump into discussion? Thank you. So in any case, additionally, 2 years to build a gigafactory, not even solid state. So what I've got here is that solid state is also one of many solutions. I am bullish on it. I want solid state to win. But what I see coming is that it's going to get adopted into commercial electronics in this 2025 range very readily. Samsung is already working on that. But I don't know that we're going to see solid state EVs show up for about a decade. And about 15 years out is when it'll be more of a mass market thing. The catch here and the big ticket item, in my opinion, is how well solid state can integrate onto existing infrastructure. Because if it can integrate to a gigafactory, you're going to see a lot faster adoption than if it needs to be a standalone system.
I heard you guys talking back and forth when we were having coffee the other day, and I gather there's some back and forth on it. And so go for it.
Yeah, in some ways, I don't disagree with James on solid state. I think the way people are pursuing it with solid state is typically with a solid lithium anode and a ceramic glass-like electrolyte. And James highlighted the key challenges there. And there are some really key challenges with those technologies and making those work. And we've seen different time frames. I've seen a report by Toyota that says they've been working with solid state. They've had them in the vehicles now for 5 or 6 years, and they'll be launching something before 2025. Toyota surprised everybody with their initial Prius launch. It was years ahead of what anybody thought would happen. So I'm not going to discount Toyota from being able to do something. But we also know from seeing some of these other competitors, QuantumScape, Solid Power, Solid Power, I think when I started at Prieto 4 months ago, their target was 2025. I recently seen something from their CEO saying 2027, 2028 for their first commercial vehicles. So their timelines are slipping. QuantumScape appears to still be in the fundamental research stage. What I would say is the key thing for the industry is it needs to solve these issues with range anxiety, fast charging, safety, so that you can, and cost. Cost is a key one. You have to get down to a low cost so you can get vehicles that are compromised or non-compromised and compare favorably to the lower cost vehicles like on a Honda Accord or a Ford Focus or what have you.
Cost threshold on cost per kilowatt hour, what does it have to come to make it,
The target's around 100 kilowatt hours, $100 per kilowatt hour.
Okay.
Is where they need to be. So when I look at Prieto, we're a 3D advanced battery manufacturer, developer and manufacturer, and we developed a 3D architecture. And why we say it's solid state, it's quasi-solid state because it's a polymer electrolyte. It's not a ceramic solid electrolyte. What it does is it does solve the safety issue, but it doesn't have all the issues that James was talking about as a pure all solid state battery. So we believe we have a working prototype. We do have a working prototype, small, and we're now ready to start scaling it. And we are working with a smaller auto company that allows us to move very quickly with regards to testing, prototyping, and getting vehicles out there. So we do believe that we can get there in 2025. It's going to be a challenge, but that's our goal, and we expect that we can be able to achieve that. With regards to competitors, I've heard different things. Hydro-Quebec, who was part of the original lithium-ion battery years and years ago, is working with ceramics and solid lithium, and they're talking at least 15 years. So very consistent with what James is talking about. So, but again, I think it's key for the battery industry to get to this market quickly so that you can shut the door on hydrogen fuel cells, and you can start looking at these high volume manufacturing.
And you don't, just to make clear, because you think that you make a strong case that batteries are okay up until maybe package trucks, and then beyond the Series P chassis or whatever you call that package truck, in the semis, et cetera, it's fuel cells are probably going to have an advantage. Is that accurate?
Yeah, if you can get the hydrogen fuel infrastructure in place, I think that's still their Achilles heel. You got to have the hydrogen available. But from a pure vehicle standpoint, on a semi truck that's hauling 80,000 pounds across country, if you take 10,000 pounds for batteries, that's 10,000 pounds that they don't get to get paid for. So it just doesn't make it economic. A fuel cell system will be much smaller, a lot less weight. So it makes more sense. So I think that's absolutely true.
And just because I didn't get a chance to say this before, Gabe, did you see the picture of the bolt on fire?
Yes, I did, and I'm pleased to report that my bolt has not yet caught fire.
Yeah.
You know, these vehicle fires, I do want to say that battery electric vehicle fires are, in my opinion, over sensationalized. And I don't know the statistics on battery fires per mile traveled, but I do know that about 130,000 internal combustion engine vehicles catch fire every year in the United States. And I don't think, so in terms, and I don't know if anybody has been burned to death by a battery fire yet. So I'm not sure how crucial this safety issue really is.
Okay, I'm just trying to make it interesting here, Gabe. So, I agree with you, Gabe. I just talked one of my friends into buying Bolt. So,
but I do now carry a package of marshmallows wherever I drive, just in case.
Just in case, okay. James, go for it.
Oh, I was just gonna say I totally agree with Gabe, and I actually. I can't stand this picture, even though I used it, because, this gets talked about very commonly at some of the trade shows I would go to, where this one picture caught more headlines and got more interest than anything else, right? And you've got, dozens, we'll say, at best, of EV fires in a year. Whereas internal combustion, you said 130,000 a year. Maybe that's just the U.S. Like there's multiple per day. You don't hear anything about those.
James, I'm going to ask you to change the slide, because I just talked my friend into buying a Bolt. And when I saw this latest round of news about the Bolt, I was like, oh God. Anyway, okay. So did you have things to say relative to Mike's? It comes down to the.
Oh yeah, no, I would say. I'm totally on board with Mike generally, and would support the notion of get something out. I have experience at this point with both legacy and non-legacy OEMs, and can see how they do and do not move quickly. So I'd say if there's any chance of earlier, 2025 kind of delivery, it's going to be with a non-legacy, but that's just my opinion.
Yeah, I would say again, Toyota, you don't want to count them out.
No.
and they've been downplaying battery electric vehicles, and we actually had a conversation with the head of Toyota here in North America as part of the Energy Fellows, and they talked about the fact that they're all about hybrids right now, and that the battery electric vehicle is only going to be, a little golf cart specialty vehicle, 45 miles that you just take to the store and all that, and they'll play in that space, but they don't believe that the long-term Model S Tesla is going to be the place where they're going to play. Yet you hear, and if you look hard, you see that they've been developing solid-state batteries since, 2006, something of that nature. I mean, they've been doing this for a very, very long time. They don't publicize it because they don't have to. They're not like a small startup that's trying to raise $100 million. They're a legacy company that has billions of dollars of cash flow that invest long term. They look out 50 years as their planning horizon. They're not like a U.S. company that looks out for the next 4 quarters. They're looking out 50 years, and they've been investing time and energy in these batteries for a long period of time. So I'm not going to discount them that they don't come next year with a new car that's solid state batteries that charges in 10 minutes and away you go. Maybe surprising, but because it is hard, but I don't know, that I wouldn't discount them.
Okay. Do you have anything to say back to him, James?
No, I totally agree. And I think to your point earlier, Steve, it's these bigger companies can throw a lot of money at something and move some serious, goals. But at the same time, they've got themselves to drag along, if you will, right?
Get out of their own way. They got to get out of their own way.
Exactly.
They've got the money for the bets, but they can't make the bets because they can't get out of their own way. That's what we see.
Pretty much. So, I mean, I'm not saying anybody's out, but, early timelines are tough to hit when you're kind of that big and have a lot of momentum in a different direction already.
Okay. Jerry, what do you have to say? I see you talking about hydrogen fuel cell vehicles, et cetera, et cetera. You were talking about energy delivery. You're saying it has to be taken away from the customer. Are you talking about wireless charging systems? Is that what you're talking about?
No, the mechanism inside the guideway has to provide for energy delivery. It needs to be completely hands-off. The customer should have nothing to do with how the energy gets made or how it's delivered. They just drive. And that's our job as manufacturers, is to provide the public with what they need.
And so you're working on systems that might be able to solve that problem.
Yeah, we have 4 patents, and we won the ZEV Challenge with the U.S.-China Innovation Summit, and that's coming up again in about 2 weeks, and the Chinese are looking to get us funded, so cool. We're excited. We're 7 out of 200 companies are in this competition, and if we narrow it down to 1, then we're set, good to go.
So BYD's made the transition, but it'll be interesting to see how just talking generally about the idea, China has this huge EV market, and most of their product doesn't make it to the U.S., but NIO is coming, and they're doing battery as a service. Tell me about that, Jerry. What's their strategy on battery as a service? Do you know about it?
No, our battery as a service is this battery mule, and the battery fits in this fireproof box. And we don't really care what the battery is that we stuff in there, because it's totally replaceable battery to battery. But the customer doesn't own this battery mule or the drivetrain for the street. It belongs to a franchise that's selling energy. And so we have a continuous profit flow from energy as a service, basically. But we do a rolling battery swap. So at 40 miles an hour, you drive us a little hole in the ground in the pavement, and you get a full charge. And you drive another couple of miles, and you get another full charge, and another couple of miles, again. So the packet of energy is much, much smaller. So the battery that you need to power all the battery cars in the world drops by at least a factor of 4. And because the car is energy efficient from the aerodynamics and the rolling friction, it uses way less energy. So the combination of way less energy and a much smaller battery is we need a battery that has a lot more cycles, which we could use definitely, because we are cycling a lot more, but we're going to shallow discharge. So the depth of discharge makes a huge difference, at least with lithium batteries, in how many cycles they'll do, between 2,000 and 300,000 for an example.
So I'm going to stop you here, Jerry. Do any of the audience have questions? No? Okay. Great. I'll let anybody got James, anything you want to say in summary, or Mike? Or Gabe?
No, I'm just excited, that solid state is getting quite a bit of attention. generally. I think lithium ion is kind of paving the infrastructure path, while at the same time being, it in and of itself a new technology. So I am hopeful that with that infrastructure, that other, call it beyond lithium ion architectures, will be able to move more quickly into appropriate niche markets. And that goes for non-batteries as well. Maybe it's fuel cells for trucking, or, different applications, inner city versus, rural, what have you. So I think we're going to see a divergence through 2020, but who knows? I'm excited either way.
Okay. Mike?
If I could just say a couple things. One, with regards to what Jerry's doing, it sounds very interesting, and I think it just highlights the fact that there is a strong push today in the world for cleaner solutions for transportation and to decarbonize our energy, because we have climate change, and I think that's really starting to become very real for governments. They're really starting to push that. A lot of people are pushing for COVID-19 recoveries that are green, and there is a significant push for these kind of technologies. And James and I have talked about this offline in the past as well. I think Pareto is going to be successful. I think we have a battery that can get out there and can address these issues and is going to be successful, but we can't be the only one. There's got to be multiple technologies out there that win. I mean, we're talking about going from, 8 gigafactories today to hundreds of gigafactories by 2030 if we're going to achieve these kind of things, this transition to a full battery electric vehicle marketplace. So it's going to be a massive change. We're going to need multiple solutions, just like you don't have one internal combustion engine today. You've got diesel, you've got renewable natural gas, you've got high-powered engines, 3-cylinder engines, you got all sorts of different things. And all customers are going to want different types of vehicles, and you're going to have different types of batteries. And there has to be different solutions. There has to be multiple winners here. There's only one, it's not going to work. And we're going to have a challenge. So that's the one thing I would say. I think it's a great time to be in the energy space in this transition, and I think there's going to be a lot of winners and a lot of opportunities out there.
Cool. Gabe?
I'm super excited about solid state batteries, and I had a lot of questions about them, and you guys did a great job of filling us in on what's going on.
All right.
Thank you.
James, thank you. We really appreciate it. Really great
questions. I'm happy to hear you out or connect. Steve, feel free to make any connections necessary.
I'm going to do that right now, actually. So thank you for reminding me. Well, give it back to me. Let's see. What am I going to do? So this is Gabe's contact info. That's my contact info. There's Mike, his contact info, and there's James' contact info. jtrevey at forgenano.com, Mike at mmrosenberg.com. Me, I'm pretty easy to find, and that's Gabe up there. So if you want to contact any of these guys, feel free. Thank you for tuning in. We appreciate it. There's a great webinar. Thanks, Mike and James and Gabe. I appreciate it.
All right,
thank you, Steve.
All right, thank you.
All right, take care, guys.
Take care.